Hello friends, welcome to our lesson on vectors today. Our concern will be explaining scalar products of two vectors. Suppose we have a vector A, then being inclined at an angle this way. Automatically, if you look at the right triangle here, and we want to find the hypotenuse of this vector, automatically this part, the way the vector is superimposed, should be vector A cos theta. And then you have another vector B being superimposed this way. This hypotenuse of this triangle will be called vector B cos theta. Now, if these two vectors are being joined together on the same straight line, the distance from vector A to the end of vector B will be the absolute value of vector AB cos theta. Automatically simply means that if we are multiplying vector A to vector B on the same straight line, we are going to have a scalar product AB cos theta. Now I need to explain something here. Supposing you have the lines, let's say points, the numbers, let's use real numbers like scalars, A plus B into A plus B. We know that normally we are going to multiply this, and then multiply this to get A squared plus B squared plus 2AB. But this will not be the same in vectors. Suppose we have vector A as A sub 1 I hat plus A sub 2 J hat. Then we have vector B as B sub 1 I hat then plus vector B sub 2 J hat. Now you have to multiply vector A times vector B to get this. In this case, vector AB will be, you are multiplying A times A sub 1 I hat times B sub 1 I hat. That will give us A sub 1 B sub 1 A sub 1 B sub 1 I hat times I hat, because we have I here and I here. So let's look at we are going to multiply A sub 2 by B sub 2. We are going to have A sub 2 B sub 2 J hat times J hat. Then plus this other part, we are supposed to have A sub 1 I hat times B sub 2 J hat. Let's just look at that. A sub 1 I hat, B sub 2 J hat. So let's call this part as A sub 1 B sub 2 I hat J hat. Then in the same vein, we also have A sub 2 J hat and B sub 1 I hat. So let's say A sub 2 B sub 1 I hat J hat. Now let's explain something here. When we have the same vectors, that is I and I, like the x-axis, they refer to parallel vectors. Now let's use this formula here, AB cos theta. So when you have two vectors that are parallel to each other, so you have I and we also have I because they are on the same x-axis. It simply means that the angle between the two vectors will be 0. So that means theta is equal to 0. Now if theta is equal to 0, let's look at cos 0. So cos theta is equal to cos 0, which is equal to 1. From the concept of trigonometry, we see that cos 0 is equal to 1. And mathematically, this I hat and I hat will now become 1. Then let's come back to this part, J hat and J hat will also be Sorry, j will also be 1. 2 j hats will be 1. J hat is 4. Let's look at the other part. If you have ij and ij, ij and ij simply means perpendicular vectors. So when two vectors are perpendicular, I mean that the angle between them is 90 degrees. And in this case, cos 90 is equal to 0. So since cos 90 is equal to 0, it means that this ij will be 0, hence the entire vector here, ij is also 0. That is why if we are multiplying vector A by vector B, our outcome will also be a scalar. Let me explain that point clearer. So if we have vector A times vector B, we are going to have A sub 1, B sub 1, and then plus A sub 2, B sub 2. Remembering that the vectors here that show the angle between the two vectors I and I gave us 1. So we don't longer have the angle here because cos theta, cos 0 is 1. Same thing here, cos 0 is also 1. But this part will change to 0 since cos 90 is equal to 0. Hence, this will be the product of two vectors if they are expressed as column vectors. And so that explains scalar products of two vectors. If we look at the condition where the vectors are parallel and where the vectors are perpendicular. But for vector product of two vectors, the reverse is the case. In that sense, we are using the sign, no longer cosine. Thank you so much.